troubleshooting voltage issues on cable lines requires a systematic approach. Firstly, thoroughly inspect the electrical system, ensuring that all outlets, switches, and wiring are properly grounded. Use a multimeter to check continuity between ground wires and ground rods or water pipes. Inspect the electrical panel for loose connections, damaged breakers, or evidence of arcing. Secondly, isolate the issue by disconnecting the furnace from the electrical system. Remove all electronic devices from the home, including televisions, computers, and appliances. If the voltage between cable lines and ground persists, the issue likely lies in the home's wiring or electrical system. Thirdly, check the furnace. Reinstall the furnace and check if the voltage between cable lines and ground reappears. Inspect the furnace for any signs of arcing, loose connections, or damaged components. Ensure that the furnace is wired correctly and that the neutral and ground wires are connected properly. Other potential causes should be considered. Reverse polarity can cause problems, so verify that the outlets and wiring have the correct polarity, black wire to hot, white wire to neutral. Large inductive loads such as motors or transformers can create voltage transients. Check for any such loads in the home. Cross-wiring should be examined, so ensure that there is no cross-wiring between the cable lines and other electrical circuits. Here are some tips for pinpointing the issue. Use a multimeter to measure voltage between cable lines and ground at various points in the home. Trace the cable lines back to their source, cable box, modem, etc. to isolate the potential issue. Remove electrical devices one by one to see if the voltage disappears. Consult with a qualified electrician to further diagnose and resolve the issue if necessary. Additional considerations include the fact that an inductive tester may not always provide accurate readings. Consider using a multimeter for more precise measurements. Flickering lights can be caused by voltage fluctuations, which can be caused by a variety of electrical issues. Ensure that all cable connections are tight and secure. In more detail, when inspecting the electrical system, pay close attention to the grounding system. The grounding system is designed to provide a safe path for electrical current to flow in the event of a fault. A properly grounded system will help to prevent electrical shock and fire hazards. Check the ground wires at each outlet and switch to make sure they're securely connected. Look for any signs of corrosion or damage to the ground wires. If you find any problems, repair them immediately. The electrical panel is the central point of the home's electrical system. It contains the breakers that protect the circuits in a home. Inspect the breakers for any signs of damage or overheating. Make sure that all of the breakers are properly labeled. If you find any breakers that are not labeled, label them immediately. Loose connections in the electrical panel can cause a variety of problems, including voltage drops, flickering lights, and even fires. Tighten any loose connections that you find. When isolating the issue, it is important to disconnect the furnace and all electronic devices from the electrical system. This will help to narrow down the source of the voltage on the cable lines. If the voltage disappears after disconnecting the furnace, then the furnace is likely the source of the problem. If the voltage persists after disconnecting the furnace, then the problem is likely in the home's wiring or electrical system. When checking the furnace, look for any signs of arcing, loose connections, or damaged components. Arcing can occur when electricity jumps between two conductors. This can create heat and sparks, which can ignite flammable materials. Loose connections can also cause heat and sparks. Damaged components can also cause electrical problems. Make sure that the furnace is wired correctly and that the neutral and ground wires are connected properly. The neutral wire is the white wire, and the ground wire is the green wire. These wires should be connected to the neutral and ground buses in the electrical panel. Reverse polarity can occur when the black and white wires are switched at an outlet or switch. This can create a shock hazard. Use the multimeter to check the polarity of each outlet and switch. The black wire should be connected to the hot terminal, and the white wire should be connected to the neutral terminal. Large inductive loads can create voltage transients. Voltage transients are brief spikes in voltage that can damage electronic devices. Inductive loads are devices that use coils of wire to create a magnetic field. Examples of inductive loads include motors, transformers, and fluorescent lights. Cross-wiring can occur when the cable lines are accidentally connected to other electrical circuits. This can create a variety of problems, including voltage on the cable lines, electrical shock hazards, and interference with electronic devices. When tracing the cable lines back to their source, look for any signs of damage or loose connections. Make sure that the cable lines are properly grounded. Use a cable tester to check the continuity of the cable lines. Removing electrical devices one by one can help to isolate the source of the voltage on the cable lines. If the voltage disappears after removing a particular device, then that device is likely the source of the problem. A qualified electrician can help to diagnose and resolve complex electrical problems. An electrician has the training and experience to safely and effectively troubleshoot electrical issues. They can also perform electrical repairs that you are not qualified to do. Remember that inductive testers may not always provide accurate readings. Inductive testers are designed to detect the presence of voltage without making direct contact with the wires. However, inductive testers can be affected by nearby electrical fields. This can lead to inaccurate readings. A multimeter is a more accurate way to measure voltage. Flickering lights can be caused by a variety of electrical issues. Voltage fluctuations are one of the most common causes of flickering lights. Voltage fluctuations can be caused by problems with the electrical system, such as loose connections, overloaded circuits, or faulty equipment. Flickering lights can also be caused by problems with the light bulbs themselves. Make sure that all cable connections are tight and secure. Loose cable connections can cause a variety of problems, including voltage drops, signal loss, and interference. Tighten any loose cable connections that you find. When troubleshooting electrical problems, it is important to be safe. Always turn off the power to the circuit before working on it. Use caution when working with electricity. If you are not comfortable working with electricity, call a qualified electrician. Consider the age of the wiring. Older homes may have wiring that is not up to current standards. This can lead to electrical problems. If your home has old wiring, consider having it replaced. Pay attention to the types of light bulbs you are using. Some light bulbs, such as incandescent bulbs, use more energy than others. This can put a strain on the electrical system. Consider switching to energy-efficient light bulbs, such as light-emitting diode bulbs. Be aware of the total load on each circuit. Each circuit in the home is designed to handle a certain amount of electrical load. If you overload a circuit, it can trip the breaker. Avoid overloading circuits by spreading out the electrical load. If you are experiencing frequent electrical problems, it is important to have your electrical system inspected by a qualified electrician. An electrician can identify any problems with your electrical system and recommend the appropriate repairs. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electricity, call a qualified electrician. Remember that electrical work can be dangerous. If you are not careful, you could be seriously injured or killed. Only perform electrical work if you are qualified to do so. Always follow all safety precautions when working with electricity. Consider power quality issues. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can cause a variety of problems, including flickering lights, equipment malfunction, and data loss. If you suspect that you have power quality issues, contact your local utility company. Look for signs of water damage. Water damage can damage electrical wiring and equipment. This can create a shock hazard or a fire hazard. If you see any signs of water damage, call a qualified electrician. Check for aluminum wiring. Aluminum wiring was used in some homes in the 1960s and 1970s. Aluminum wiring is more likely to corrode than copper wiring. This can lead to electrical problems. If you have aluminum wiring, have it inspected by a qualified electrician. Consider surge protection. Power surges can damage electronic devices. Surge protectors can help to protect your electronic devices from power surges. Use surge protectors on all of your valuable electronic devices. Be mindful of energy vampires. Energy vampires are devices that continue to draw power even when they are turned off. Energy vampires can waste a lot of energy. Unplug energy vampires when you are not using them. Review the electrical code requirements. The electrical code is a set of standards that regulate the installation and maintenance of electrical systems. The electrical code is designed to protect people and property from electrical hazards. Make sure that your electrical system complies with the electrical code. Consider using a home energy monitor. A home energy monitor can help you track your energy consumption. This can help you identify ways to save energy. Keep a record of electrical problems. If you are experiencing frequent electrical problems, keep a record of the problems. This record can help an electrician diagnose the problem. Be patient when troubleshooting electrical problems. Electrical problems can be difficult to diagnose. It may take some time to find the source of the problem. Don't give up. With persistence, you will eventually find the problem and fix it. Remember to document all your findings. When troubleshooting electrical problems, it is important to document all of your findings. This documentation can help you or another electrician troubleshoot the problem in the future. Consider using a systematic approach. A systematic approach can help you troubleshoot electrical problems more efficiently. Start by gathering information about the problem. Then, develop a hypothesis about the cause of the problem. Next, test your hypothesis. Finally, if your hypothesis is correct, fix the problem. Keep safety in mind. Safety should always be your top priority when troubleshooting electrical problems. If you are not comfortable working with electricity, call a qualified electrician. Use the process of elimination. The process of elimination can be a helpful way to troubleshoot electrical problems. Start by eliminating the most likely causes of the problem. Then continue eliminating causes until you find the problem. Ask for help if you need it. There is no shame in asking for help when you are troubleshooting electrical problems. If you are stuck, ask a qualified electrician for assistance. Review electrical diagrams. Electrical diagrams can be helpful in understanding how an electrical system is wired. If you are not familiar with electrical diagrams, take some time to learn how to read them. Check for any recalls or safety alerts. Check for any recalls or safety alerts on electrical equipment. This can help you identify potential problems with your electrical system. Stay informed about electrical safety. Stay informed about electrical safety by reading books, articles, and websites about electrical safety. This will help you stay safe when working with electricity. Remember to always disconnect the power before working on any electrical equipment. This is the most important safety precaution you can take. Use insulated tools when working with electricity. Insulated tools can help to protect you from electrical shock. Wear safety glasses when working with electricity. Safety glasses can help to protect your eyes from flying debris. Work in a well-lit area. Working in a well-lit area can help you see what you are doing and avoid accidents. Don't work alone. It is always a good idea to have someone else present when you are working with electricity. This way, if something goes wrong, someone can call for help. Don't work when you are tired or distracted. Working when you are tired or distracted can increase your risk of accidents. Take breaks as needed. If you are working on a complex electrical problem, take breaks as needed. This will help you stay focused and avoid mistakes.